Video number 9. I want to throw more light on the issue of logarithm. The issue of logarithm. Note that the log of the integral of 1 over x, the integral of 1 over x is equals to log x to base e. Log x to base e. We either call it log x to base e or ln x. Ln x. Ln x. That is, this is plus c. Plus c. I.e., the integral of 1 over x, the integral of 1 over x dx, that means I want to integrate 1 over x with respect to x. The integral of 1 over x dx is equals to log x to base e plus c, or I simply write log x plus c. The base may be silent, but in this case we know it is to base e. It is to base e. E is the natural log. Either I write log x or I write ln x plus c. Ln x plus c. So, in the same manner, also the integral of 1 over any letter, 1 over y, the integral of 1 over y dy is equals to log y to base e plus c, or ln y plus c, or simply log y plus c, where the base here is silent. So this is, so in the same manner, log, that is the integral of 2 over x plus 1 dx is going to be log x plus 1 to base e plus c, which is the same thing as ln x plus 1 plus c plus c plus c. So take notes. The integral of 5 over the integral of 5 over 2x plus 1 dx is the same thing as log that is the same thing as 3 log 5 log 2x plus 1 everything over d dx of the core, the expression inside the bracket, which is 2x plus 1, then everything plus c. So this is equals to 5 log 2x plus 1 over now d dx of 2x plus 1 is 2, so plus c. This is equals to 5 over 2 log 2x plus 1 plus c. If I like, I can put the base, which is e. Another way is to write it as 5 over 2 ln 2x plus 1 or plus c. So this is the answer. Let's take note of this. Take note of this one. So now take note of this. Take note of this. So therefore the integral of 4x minus 5 over x plus 1 into x minus 2 dx is the same thing as, remember that we first of all resolve this algebraic fraction 4x minus 5 over x plus 1 into x minus 2 into partial fraction, and we got the integral of 3 over x plus 1 dx plus the integral of 1 over x minus 2 dx. So let me repeat this very line, the other page. This is, now I am saying that the integral of 4x minus 5 over x plus 1 into x minus 2 dx is equivalent to the integral of 3 over x plus 1 dx plus the integral of 1 over x minus 2 dx. That is as before. So now what am I saying? I'm saying that the integral of this fraction 3 over x plus 1 is the same thing as 3 log x plus 1 to base e, then plus the integral of 1 over x minus 2 is the same thing as log x minus 2 to base e, or plus c. So now I cannot write it this way, or 3 ln x plus 1 plus ln x minus 2 plus c. So I can leave it this way. That is what I'm saying. That's my answer. Now from here I go to integration by algebraic substitution. I go to integration by algebraic substitution. But before then, let me go to example 2. Example 2. I think this was my example 2. Evaluate the integral of 4x minus 23 over x minus 5 square dx. Now 4x minus 23 over x minus 5 all square is an algebraic function. So first of all, we resolve this 4x minus 23 over x minus 5 all square into partial fraction first. Here, that is solution. Here, we first of all resolve the given algebraic rational function into its partial fractions. Say let 4x minus 23 over x minus 5 all square be equivalent to a over x minus 5 plus b over x minus 5 square. Remember, consider this denominator, the denominator x minus 5 all square. This is a repeated linear factor. And you remember, when we apply the guideline for solving partial fraction, in a given algebraic fraction with a repeated linear factor, there corresponds, if we have a denominator of this nature, which is a repeated linear factor, now the partial fraction will be of the form a over the linear factor, which is x minus 5, then plus b over the quadratic factor, which is x minus 5 all square. Remember, we are applying the guideline on solving partial fraction, having a repeated linear factor in this case. Now, what do we do here? We clear the fraction. Clear the fractions. So if we do that, we have 4x minus 23 is equivalent to a into x minus 5 plus b. That's what we have. So call this identity 1. You choose a value of x. That we eliminate a, so that we can solve for b. Now at x equals 5, equation 1 becomes 4 into 5 minus 23. 4 into 5 minus 23 is equals to a into 5 minus 5 plus b. 5 minus 5 is 0, so 0 times a is 0, so 20 minus 23 is equals to a into 0 plus b. Therefore, minus 3 is equals to b, or b equals minus 3. Now, how do we solve for a? We can we can equate constants. Or we can expand first. Expand the right hand side of equation 1. So if I do that, I have 4x minus 23 is equals to ax minus 5a plus b. Plus b. Call this identity 2. Identity 2. So here I can now equate constants. Equate constants. Equate constant terms in equation 2. Equate constant terms in equation 2. Equate constant terms in equation 2. If I do that, at the left hand side of equation 2, the constant term is minus 23. So I have minus 23 is equals to minus 5a plus b. So this means that minus 23 is equals to minus 5. And what is a? What is a? Do we know a? We don't know a. So minus 5a plus b. And what is b? Minus 3 plus minus 3. So this means that 23, that is minus 23 is equals to minus 5a minus 3. Collecting, that's rearranging the terms. I have minus 23 plus 3 is equals to minus 5a. Therefore, minus 20 is equals to minus 5a, or a equals minus 20 over minus 5. This is equals to 4. So a is 4. A is 4. Then I can now write my partial fractions. Therefore my partial fraction now, 4x minus 23 over x minus 5 all square is equals to a is 4 over x minus 5 plus b is minus 3 over x minus 5 square. So I have 4x minus 23 over x minus 5 square is equals to 4 over x minus 5 plus minus is minus 3 over x minus 5 square. Hence, so this is my partial fraction. I can now use this result of the partial fraction to answer the question, to integrate. Therefore, the integral of 4x minus 23 over x minus 5 square that is the x is equals to the integral of 4 over x minus 5 dx minus the integral of 3 over x minus 5 square dx. So now what do I do? This is equal to, now the integral of 4 over x minus 5 is going to be 4 log x minus 5 to base e. Then minus, this is going to be minus, this will be the integral of 3 into x minus 5 all raised to power minus 2 dx. I have to rewrite this in this form first. For this 3 is a constant, so this is equals to 4 log x minus 5 to base e. This 3 can be outside. Minus 3 times the integral of x minus 5 raised to power minus 2 dx. So this is going to be 4 log x minus 5 to base e. Now minus 3, I have to raise this power by 1. So that will be 3 into x minus 5. If I raise the power by 1, it will be now raised to power minus 1, because minus 2 plus 1 is minus 1. Then over that new power, which is minus 1, then times d dx of the core, which is x minus 5, all plus c. So that is going to be 4 log x minus 5 to base e. Minus is plus. 3 into x minus 5 raised to power minus 1. Everything over d dx of x minus 5 is 1, all plus c. So I can rewrite as 4 log x minus 5 to base e plus 3 over x minus 5. When this one comes down, remember the power will now be plus 1. So all plus c. This is my final answer. Or still 4 ln x minus 5 plus 3 over x minus 5 plus c. This is my final answer. So this is application of partial fraction and integration. So we call this topic integration by partial fraction. This is how we handle that.